original vector, right? Suppose that this is vector A. I am writing this is vector A. A small vector of unit length is considered on the same vector. So this is unit vector. Yeah, then this is what is called unit vector A. That means the direction of this unit vector is as the direction of the parent vector, right? Okay. This is the child vector, and this is the parent vector, and this is the child vector. That is why it is capped. Unit vector is denoted as A capped, B capped, C capped, etc. Capped. This is capped. Am I correct? Small children are given cap, right? Dad is moving in a forward direction, and the child is also moving along the same line in the same direction the dad is moving, right? The little one of a big vector is called what is called a unit vector. What is the unit vector A? Unit vector A is equal to A capped. What is the unit vector of B? That is equal to B capped. What is the unit vector of C? That is C capped. This is vector C, and the unit vector is what is called C capped. This is vector B. What is the unit vector? Unit vector is what is called B capped, etc., etc. Am I correct? Unit vector is equal to, suppose that unit vector A. Unit vector A is equal to the whole vector divided by modulus of the vector. The total vector must have magnitude as well as direction divided by magnitude. Then what will remain? Only direction will remain, because its magnitude is unity. A vector having its magnitude unity but has the direction of the parent vector is called unit vector. This is a very important formula. Unit vector A is equal to whole vector divided by, whole vector means total magnitude and direction. That whole vector divided by the magnitude of the whole vector is equal to unit vector, right? One more. This can also be written as like this also we can write. That is vector A divided by simply A also we can write. Because either modulus, within modulus the vector is kept, that also said as equal to modulus vector, or simply write the letter only, then also that is called a modulus vector, right? Only magnitude, this also magnitude. Magnitude can be represented like this, and also magnitude can be represented like this also. So from this relation we can write the whole vector A is equal to magnitude of the vector into unit vector. So this is also very important relation in vectors. The whole vector is equal to magnitude of the whole vector into its own unit vector. So from this analysis, what you understand is that unit vector represents only magnitude, right? The total magnitude of a vector into the direction of the unit vector means whole vector we are getting. This is a very important relation. Vector A is equal to unit vector A into, or modulus vector. This way also we can modulus vector A into unit vector A. This is what is called unit. It's a very important relation. So this relation is also important. This relation is also important. So unit vector, that also done. And the next what I am going to tell you is unit vectors, right? Orthogonal vectors are unit orthogonal vectors. Unit orthogonal vectors means those vectors which are perpendicular to each other, one another, are called orthogonal vectors. For example, we have the coordinate system. Coordinate system means this is x-axis, this is y-axis, and this is z-axis. It is actually drawing like this only. If you stand at the corner of a table, one side along the parallel your right hand is x-axis and the other is y-axis, and you're standing at the corner and your head is along the z-axis. So at the corner of a table, if we erect an object, a linear object, that will give you the z-axis, and one is x-axis, other is y-axis. But when we draw the coordinate system, right, in a paper or on the board, we have to write z along this direction, or z is this and this is y. That also possible, right? That is accordingly as the coordinates. So this is what is called the coordinate system. So coordinate system is very necessary because without an origin, we cannot, without an origin and this x-axis and y-axis and z-axis, we cannot study the motion of a body. So in physics, many times we have to study about the motion of a body and we have to calculate velocity, displacement, acceleration, momentum, many things we have to calculate, for which we need a system, a coordinate system with respect to which or using that only we can find the position of the body, the displacement of the body, velocity of the body, acceleration of the body, etc. The position where you stand at is what is called origin. Observer's point is called origin, right? Okay. So these are the things about. Now what we have to talk about is a unit vector along the x-axis. How is unit vector along the x-axis represented? So unit vector along the x-axis is a vector having magnitude, unity, and acting along the x-axis. Acting along the x-axis. And this is the origin O I am writing here. This I will write I cap. What is called I cap? Is small I with this cap is the unit vector along the x-axis, right? Suppose a body is moving in the plane of xy plane. When the body is moving the xy plane, its x coordinate and y coordinate both are changing. Both are changing, right? So it's a displacement along the x-axis we have to calculate sometimes. It's displacement along the y-axis also we have to calculate sometimes. That time we will need the help of unit vector. The magnitude, suppose the body, a body has moved at this point. X distance the body has moved along the x-axis, and y distance the body has moved along the y-axis. The body has started from somewhere and was moving in the plane. At any instant, the body has reached at a point P. When the body reaches at a point P, it has a distance x moved by it along the x-axis, and a distance y it has moved along the y-axis. Am I correct? So it has two displacements. Body is actually moving in a plane, but at the same time it has displacement in two directions, one along the x-axis and other along y-axis. What is the displacement of the body along the x-axis? That is equal to vector x. That is equal to vector x. Vector x I can write as equal to the total displacement in magnitude x into I can write. Right. Vector x is equal to x into I cap or xi cap. Right? What is the displacement of the body along the y-axis? That I can write as equal to vector y is equal to y into j cap. I can write. Suppose that a fly is moving up in the space. That time we have to use three coordinate system. A house fly is moving up at any instant. It is in the space, right? The displacement of the body is in three directions. The body has moved a displacement along the x-axis. It has moved a distance in the y-axis, and also it has moved a distance in the z-axis. It has three displacements. Such motion is called three-dimensional motion. But if a body is moving in a plane, that motion is called two-dimensional motion. Two-dimensional motion means that displacement can be described using two displacements, one along the x-axis, other along the y-axis. Suppose if a body is moving into space, in that case, the displacement of the body can be measured using three displacements.